First, let's talk about the digit representation. You must have seen while practicing with the digits that there are plenty of questions regarding 2-digit, 3-digit, 4-digit, and goes on. For example, if I consider a 2-digit integer, for example, I have AB, for example, that is 22. How can I represent this? I can also represent for, okay, let me start with the digit first. Okay, so let's get start. For example, if I have a decimal D, E, F, G, E, H, right? So this is decimal point. This is unit digit or 1 digit. This is tens. This is hundreds. This is thousands. And 10,000 up to so on, right? On the right side of a decimal, this is 10th digit. Just see 10th and tens. This is 100th. And this is 1000th. On the right side of a decimal, there are decrease of 10. And on the left side, there are increase of 10. Increase of 10 times. Okay, so for example, if I ask about a 2-digit number, that is AB, for example, that is 22. Okay, so how can I present this? We can represent this as 20 plus 2, right? This can also be written as 10 into 2 plus 2, right? So that's why if we have 2-digit integer, B is unit digit and A is tens digit, right? So we can write this as 10 into A, 10 into A plus B, right? Okay, for example, if you have a 3-digit integer, A, B, C, right? The first one is unit digit C, second one is tens digit, we can write this as 10 into B, and third one is hundreds digit, we can write this as 100 into A. For example, we have 123. I can write this as 3 plus 10 into 2 plus 100 into 1. The result will be same, 123. So you got how I present these in this form, because in most of the question you have to first convert these into this form to proceed further. Everyone got this?
Yes.
Okay. For example, if I ask a question that there are two integer, two digits integer, both are 2 digits integer, right? And y, for example, x is AB and y is BA. So can anyone of you tell that if I subtract x and y, the result, what could be the result in the form of multiple? First, tell how can we subtract these? For example, we have AB minus BA. So we can write this as 10A plus B minus 10B plus A, right? If you proceed further, this is 10A minus A plus B minus 10B, right? So this will be 9A minus 9B. So this will be 9 into A minus B. So based off this, we can assume that, and we've inferred that if we subtract two integers in which digits are just inverse, because we have A, B, and in the other case we have BA, right? And if we subtract this, whatever the result is, that will just be a multiple of 9. I've seen plenty of questions using this concept, right? That's why I'm explaining this way. Everyone got this, what I did here?
Yes. This is only for subtraction cases, right?
Yeah. And if I go for the addition case, for example, for x plus y, what will be the difference here? Can anyone of you tell? This is 10A plus B.
11A
Thus,
plus 11B.
yes, exactly. This will be 11A plus B. So the result is a multiple of 11 in this case, and result is a multiple of 9 in this case. Now, let me throw a very simple question on you. What is the two-digit integer that is twice the sum of its digit? I'm asking, just tell me the two-digit integer that is just a twice, that is just equal to the twice of the sum of its digit. Be quick. I'm asking about two-digit integer that is equal to the twice of the sum of its digits. Just tell me what is a two-digit integer.
22.
22. How 22? If you just add 2 plus 2, that is 4. 4 into 8. And I'm asking any two-digit integer. If this is the case, right? This is not equal to 2 into 2 plus 2. That is 2 into 4, which is 8.
Okay.
I'm
Yeah,
asking about a two-digit integer that is twice the sum of its digits. Anyone else? Okay, so let's start.
18.
Yes, 18. For example, if I consider x as that digit, and if I call that a, b, so the question is, that digit must be equal to the twice the sum of its digit, right? And if I present this, I can represent this as in form of digit as 10a plus b is equal to 2a plus b, right? So this will become 8a is equal to b. Okay, now let's see cases. For example, as you all know that both our digits are integer. Okay, so first see that if a is 0, what could it be? B is 0. So this is not a two-digit integer. If I consider a as 1, so what will it be? This is b, right? B will be 8. And if I just sum this, 2 into 1 plus 8 is equal to 2 into 9, which is 18. Yes, this is our case. Now, if I consider a is equal to 2, b will become 16. And this is not a two-digit integer. Because we want one digit in place of b, but we are getting a two-digit. That's why if I proceed further, those will not be a two-digit integer. So our answer is 18. Got the point? How I presented this? Okay. If for the same question, I just change this question and ask that a two-digit integer that is equal to thrice. At first, this is twice. If now they change this to thrice. So I'm asking a two-digit integer that is equal to the thrice the sum of its digit. What is that integer? Just be quick.
17.
How could 17? 3 into 1 plus 7 is equal to 3 into 8, and that is 24, not 17. Okay, so now considering the same way, for example, if I again consider x as a, b, so I could write this as a, b is equal to thrice of its sum of its digits. And if I present this in decimal form, this will be 10a from the digit form. 10a plus b is equal to 3a plus 3b. And if I proceed further, this is 7a is equal to 2b, right? Now, one way is just assume the value of a and find the value of b. But there is a shortcut here. What is that shortcut is? The right side is always even integer, right? Because integer into even number is always an even integer. So the left side might also be even integer as well. So how could we have even integer on the left side? When a is 0, a is 2, a is 4, a is 6, a is 8, right? And if I consider a is 0, what is the value of b? B is also 0, and that is not a two-digit integer. If I consider a is 2, what is the value of b? That is 7, and that is 27. And if I consider 27, 27 is equal to 3 times of 2 into 7. This is 3 into 9, that is 27. Yes, exactly what we are looking for. And if I consider a is equal to 4, a is equal to 6, a is equal to 8. If a is equal to 4, what is the answer? B is equal to 14. This is not a one digit which can be placed in which can be put in place of b. If I proceed further, we will also get a two-digit integer, not a one-digit integer. So that's why 27 is that digit. If we take the sum of which is equal to the thrice the sum of its digit. Everyone got this?
How does left hand side 7a is even? If you put a as 1, 7, it becomes odd, right?
That's why I just put, because at first you can do 0, 1, 2, 3 up to so on. That will time taking. And I just told you that the right side is even. So left side must be even. So that's why I
Okay.
place 0, 2, 4, 6, and 8.
Okay, now I understood.
Okay, so this is just a bit idea about the how I should represent the digits. Let's just solve few questions for this, and then we'll proceed to the even odds. Then proceed to the unit digit and 10 digit concept. Okay, we will already discuss this. Yes. Okay, try this question. You have just 1 minute for this question. Be quick. Okay, so what's the answer? Okay, so in this question, we have a 3-digit integer, a 3-digit number, right? And let's call this number as A. And the question is, if X is the 100th digit place, 3-digit, right? And Y is the unit digit place. Okay, and the question, no, this is N. And the question is saying that the number N minus 100x minus Y is always divisible by. Okay, so let's call this A, the 10th digit at is A. We can also write this as 100x plus 10a plus y, right? And the question is saying, if we subtract this with 100x and y, So what will be the answer? This will cancel out. This will cancel out. We are left with this 10 into a, right? So whatever the value of a doesn't matter. If that is a multiple of 10, the question is saying is always divisible by what? That must be C.
I got the same answer, but I have a confusion there because 10 is an even number, right? So if we get, I got 20. If I substitute, I just put a random number as 320. Then I have got 20 as the answer. So it is 20 divisible by 10. But what about 8?
Take any
It's an
value.
even number.
Doesn't matter. Take
Yeah,
odd as well. If you take 1, this is 10. If you take 3, this is 30. Take 2, 20. All of these are divisible by 10.
Okay.
Okay, so let's move forward. Yeah, try this question. This is an interesting question. Only 1 minute for this question. Okay, so what's the answer? Anyone is solving, or shall I solve this now? Okay. If a 3-digit integer has a digit reverse, the resulting 3-digit is less than original by 297. If I call the original digit as X and let that be A, B, C, and if I call the 3-digit which is reverse as Y, and that will be C, B, A, right? And the question is saying if I subtract Y from the original, that differs by 297, right? Okay, so that will be ABC minus CBA is equal to 297. And if I present this, that will be 100A plus 10B plus C minus 100C plus 10B plus A is equal to 297. 10B will cancel out, and this will be 99A minus 99C is equal to 297, and A minus C is equal to 3. 99 is equal to 297, and A minus C came out to be 3. Till now, the question is very simple. Now you have to see cases that in what case A minus C could be 3, right? So, for example, if A is 4, 4 minus 1, the result is 3. 5 minus 2, the result is 3. 6 minus 3, the result is 3, right? Likewise, 7 minus 4, the result is 3. 8 minus 5, the result is 3. And 9 minus 6, the result is 3. Okay, so we have these 6 cases. So the answer must be 6. Yes or no? Anyone?
What are these 4, 5, 6, 7 values?
Listen, we have A minus C is equal to 3, right? So we are checking the cases that in what scenario we could have A minus C is equal to 3. 4 is for A, this whole thing is for A, and this whole thing is for B, for C, right?
Okay.
If A is equal to 4 and C is equal to 1, we will get 3. So I'm asking, the answer must be C. Is that is true? Are we missing something here?
But B will remain at the same position because like 9.
Yes. You are saying, repeat your point.
Since we are reversing it, so 9 will, like, B will remain at the same position and then B is 9. So 9
Okay,
wouldn't
so
be.
that's the case. Listen. The
Yeah.
thing is, if we are just considering A and C, we could have 6, but we are missing B. And B could be any value from 0 to 9. We have these 6 cases, right? And for each case, if I consider the first case, if I have A, B, C, and this is 4, this is 1, B could be 0, B could be 1, up to 9. For all of these, there are 10 possibilities for each of these.
So 60.
So our result is 60. So there are 10 possibilities for each of these, and total we have 6 cases, and for each we have 10 possibilities. That's why the result is 60. Got the point?
Yeah.
Everyone got this?
Yes. Yes.
These are how the question could be asked regarding, and that involves the representation part. Okay, so let's quickly solve 1 or 2 questions, and then we will proceed to the another important part. Okay, again, you have 1.5 minutes for this question. Just solve this question. Okay, so what's the answer? No one is able to figure out what is going here. Okay, we have 3-digit positive integer x integer in which x is the hundredths digit. We have x 3-digit positive integer in which a, b, c are hundreds, 10, and unit digit respectively, right? So we have x equal to a, b, c, and we have y that has k, l, and m, right? Unit, tens, and 100 digit. And a question is saying that if 2a into 3b into 5c is equal to 2 power a into 3 power b into 5 power c is equal to 12 into 2 power k into 3 power l into 5 power m. So what is the value of x minus y? First, let's simplify this. We can also write this as 5a, 3b, 5c is equal to, what is the prime factorization of 12? That is 2 square into 3 into 2k into 3l into 5m, right? Now, this is just using the property of the exponents that whenever the bases are same, the power add up. That's on right side, we will 2 into k plus 2 into 3 into l plus 1 and 5 power m. And now this is 2a into, just a moment, into 3b into 5c. Now on the both side, we are having the same basis, so we can just equate the powers. So for 2, we have a is equal to k plus 2. For b, this is l plus 1. And for 5, this is c is equal to m, right? Now if the question says that we are asked to find x minus y, you can also write this as abc minus klm. And this is, if we just first put out representation as 100a plus 10b plus c minus 100k plus 10b 10l plus m, as c is equal to m, so we cancel straightforward as cm, and a is equal to k plus 2, right? And b is equal to l plus 1 minus 100k minus 10l, right? So we were just left with 100 into 2 plus 10 into 1, which is 200 plus 10, which is 210. So I even got this, what I did here. At first, we just need some sort of relation between A, B, and C and KLM. And once we just come up with a relation, just substitute in place of x minus y after just representation of the digits. Is this clear now? Or is still there sort of any confusion in this? If no, then I'll proceed forward. No confusion in this. Okay. Now this one is just for your practice. We have just 1 minute for this question. Just speak it, then you'll proceed further. Okay, so what's the answer for this? This is exactly same question which we discussed. 9. Okay, so one answer is 9. Anyone else? Okay, so C3. So we got 2 answers, 9 and 3. Okay, so question is saying for a 3-digit number x, y, z, and the function is like this. Okay, we have a 3-digit number x, y, z. This is unit, tens, and hundreds. digit of the number, the function fxy, and we have given the function that fxyz is equal to 5 power x into 2 power y into 3 power z. So whatever we have values here that are there, the exponents of 5, 2, and 3 respectively. And if question is saying that we have f a b c is 3 times of the f d e f. So based on whatever we are provided, we can write this as 5 power a into 2 power b into 3 power c is equal to 3 into 5 power d into 2 power e and 3 power f, right? Now just using the rules of exponent, if the bases are same, the power just add up. This is 5 into d into 2 into c into 3 into f plus 3, right? And left side is 5a into 2b into 3c. Okay. Now just equate this. A is equal to d, b is equal to c, not c, e, and c is equal to f plus 3, not 3. No one has corrected me. This is 1, and when add up, this will become 1, not 3. This is 1. Now just substitute in place of what the question is saying, that a, b, c minus d, e, f. You have 3 digits, a, b, c minus d, e, f. And this will be 100a plus 10b plus c minus 100d plus 10e plus f, right? And a is equal to d, so we can straightforward cancel this out. B is equal to e, we can cancel this out, and we are left with c minus f, and c is just f plus 1. F plus 1 minus f, f will be cancelled out, and the result will be 1, not 3 or 9. So everyone got this? How I come up with this answer?
Yes.
Everyone else got this? Because this concept is pretty much common in this question.
E.
Hello?
What you are saying?
E.
E. You are saying that is E. Any other answer? Okay. Anyone who is still
A?
solving? A. Okay, so we got multiple answers. Anyone who is still solving, or shall I proceed forward? Okay, so let me explain this. We are just adding two digit integers, and as a result, we are getting a 3-digit integer, right? First of all, tell me one thing. We are adding 2-digit integers, and can we have a result 200 in any case?
No.
No. So what is the maximum possible value if we have 99 and 99? So what is the answer? 198, and that is less than 200. So first thing is that if we have a 3-digit, for being a 3-digit, the first digit must be 1, right? Okay, so based on this, if we have first as A, so A must be 1. So just modify this. This will become 1B plus B1 divided. The result is 1C. Got this point?
Yes. Yes.
Okay. Now the next point is, how can we proceed forward from this? If I consider, listen, if I consider B as less than 9, for example, from first of all, can B be 0? Can we have B as a 0
No.
value? Yes.
No.
No, because
Yes.
in that case, if this is not a 2-digit integer. So just by saying that, we can assume that B cannot be 0. Now B can be any value from 1 to 9. And first tell, can B be any value from 1 to 8? Because for example, take any value from B from 1 to 8, which you think could be the value of B.
We can't take 1 because it's saying ABC are different digits.
Okay. So I'm asking, what could be the value of B here?
9.
9. Why the value of B should be 9 here?
No,
It's
I guess
91 plus 19 will be 110.
Yes.
The reason is, for example, if you take B as, for example, 8. So this is 1, 8 and 8, 1. So what is the answer? 99,
It's 9.
which is
It's
not
not 3
possible.
digits.
So B has to be 9. So if we proceed forward, this is 9 plus 1, 10. 1 is carry on here, 9 plus 1, 10. This is 11. And this is A, this is A, and this is C. That's why C has to be 0, considering B has to be 9. And if you take any value of B less than 9, the result is not a 2-digit, not a 3-digit integer. Anyone got this? There is one more question relevant to this for the practice. And we'll jump to that question if everyone got this, what we discussed.
Can you please repeat it again? I lost my connection.
From where? From the start or from?
No, I get till when A equals to 1.
Okay, so we have 1B over B1, result is 1C, right? I just told you that B has to be 9. B can never be another value less than 9. If that is the case, for example, consider maximum value of B less than 9 is 8. So 1, 8 and 8, 1. If you sum this, result is 99, not a 3-digit integer. So B has to be 9. So 1, 9, 9, 1, sum is 0, 1, 1. So that case, we are having a 3-digit integer, which is 110. And in which C came out to be 0 and B is 9. Got the point? Yeah, one more
Yes.
question to practice. Just practice that. That will clear all your doubts. Okay, just try this question. Okay, so what's the answer?
Three.
D.
3 and 9. Any other answer? Okay, so again, we are adding a two-digit integers, and the result is a 3-digit integer. And what we discussed that the maximum, if we take the maximum value of both, that cannot exceed 200, that is 198. So based on that point, this must be 111, 111. Okay, so we have A is equal to 1, right? 1B over CD is equal to 111. First point. Okay, now how will we proceed from here? Now let's consider a case. We have 1B. What is the maximum possible value of 1B? That is 19. I'm considering maximum value. And what is the maximum value of CD? Yes, I'm asking you.
9, 9.
9, 9.
But then this says the A, B, C, and D are distinct positive integers.
Okay, so how can we proceed from this forward? Yes, just be how you got 6 and how the other person got 9.
I just plug in the numbers like 75 and 36 adds up to 111.
Yes, that is a possible case. You can do that, but that will be a bit difficult. And how the other person got 3?
Yeah, that's how I got 3.
You got 3. And how the other person got 9? No one is able to figure this out.
So in that case, we have to equate B to 8, and then we can put 93 for CD.
Just repeat your point, what you are saying. Okay, let me explain this now. We have A, B, and CD, which sums to 1, 1, and 1, right? And what we've discussed that the maximum value of the two-digit integers after adding them must be less than 200, right? Just based on these, we have got this A must be 1, right? So this is 1B CD over 1, 1, 1. Okay, so first thing is that 1B must be less than 20, right? Because at start we have 1 and this is B, that must be less than 20. The next thing is about CD, and the thing is what could be the value of C here so that we could have 3-digit integer. At this is less than 20, right? And what could be the value of C here so that the result is a 3-digit integer? Let's suppose if you take 8 here, for example, and this has 9. So what is the answer? And just keep in mind that the 1b is less than 20. And considering the maximum case, for example, that is 19, and this is 8, and this has to be 7, in case we are having a C less than 9. So what is the answer here? 9 into 7 is 6. 1 here, 8, 9, 10, 106. This is not the case. Now let's see that we have 1, 9, and if we consider C as 9, the maximum, this cannot be 9, right? So what is the value of this so that we have 1, 1, 1?
$93.
93. So what is the answer here?
111.
93, 1, and 1, 1, 1. This is just based on intuition. You don't need to solve. Just consider value and just proceed further. Everyone got this, what I did here?
Yes.
Let me quickly explain this again if you want, or shall we proceed forward? Because this is just a first type of question. We are just very much late for the unit digit and tens digit. But everyone got this, then I'll proceed further.
Can you repeat?
Okay, we have AB over CD is equal to 111, right? And based on that, the sum of two-digit integers can never be, sum of two-digit integers can never be greater than 200. That must be less than 200. So A came out to be 1, right? So we have 1B over CD is equal to 1, 1, 1. And next thing is we have 1B. This has to be less than 20. And considering the maximum value, for example, if I take 1, 9, for time being, just consider 1, 9. And what could be the value of CD so that we have a 3-digit integer? In that case, the C must start with a 9. So that because all of these digits are distinct, right? So let's change this. For getting a maximum, let's consider this is 8. And so what will the value of D so that we get 111? That has to be 3. 8, 9, 10, 11, 1 is common here. So this is. So what exactly the question asked? The question asked, what is a possible value of C? And that is 9.
Yeah.
You can change the value of C and check for other cases as well.
So the answer will be E, cannot be determined.
The answer will be
Yes.
D.
D.